words on this slide, you could either email me and tell me, why don't you get yourself together and put all your PowerPoint online, or you can just do the recording thing and make my YouTube analytics go up a little bit. Anyway, so there's that one. Let's move on to another one. So this one is more like what you're going to see on your homework. You have two things, well, actually three things you have to do. So let's read through this carefully, and then I will, oh, you know what I'll do? Let's play the numbers game. I love playing the numbers game. Here's the numbers game. From here until the end of course, oh, a couple things. From here until the end of the class, that is until May, bring your computer every day. So from now until May, bring your computer every day. That's like a little rhyme or a ditty. Maybe we can make a song about it. So that's number one. Number two is we're going to be doing a lot of problems like this where there's a lot of words. So I guess I probably should get the PowerPoint and make sure it's available online. So I'll try to make a mental note of that. But I'm going to be playing this game with you where I highlight all the numbers and then I pick people at random to tell me what those numbers represent. So because the numbers are the most important thing, right? So there it is. I think those are the only numbers. Is that right?
You missed the one at the bottom.
Oh, there is one at the bottom, but that's a separate, so there's a line here in my mind.
Okay.
I'll get down there, don't worry.
Separate answer.
Yeah, separate. We'll deal with the one at the bottom momentarily. Okay, so try to figure out what those numbers mean, and if you don't understand what they mean, I will help you, not to worry. I don't want to make anyone feel bad, at least not too bad. Okay, so Riley, when you see that 7.8, what does that represent in the context of this problem? It is the mean. Very nice. Let me write that down up here. The mean of the whole population is 7.8. So good, because we need these so that we can use them with these formulas. Next, Cooper, 1.2. What does it mean? It is. Yeah, this one's easy because it actually says mean and standard deviation. That's the standard deviation of the population is 1.2. Okay, the final one. Elisa. Did I say that right? I always am scared. I did. Excellent. Elisa, what is 150? The size of the what did you say? The sample size? It is the sample size, and I use n for that. It even says it here, so it's kind of, this one's kind of boring. But there they are. There's the numbers that we're using. We're going to do this for a lot of problems where you have to just figure out what do the numbers mean in the context of the problem. Now, let's go down to the problem here, and it says, what is the mean and standard deviation for the sample mean distribution? So what I'm looking for is this and this. So the mean and standard deviation of the sampling distribution. Here's, oh, sorry, they're over here somewhere. Here's the formulas. You can do this. In fact, I'm so confident I'm just going to pick someone out of the blue. Grayson, what is the mean of the sample distribution? 7.8? It's the same? Oh, yeah, it is. It doesn't change. The mean doesn't change. Next, the standard deviation. Liberty, what's the standard deviation of this sampling distribution? 0.97. Oh, okay, sorry. It's my hearing is going. I need hearing aids probably, but I'm too young to do that to myself. Okay, so very nice though, very good. Thank you, Liberty, and everyone who also chimed in to help me. So far, so good. Now for the hard part. So we can all do this. You're going to have to do this for your homework, but here's the one that's going to be the extra mile, and that is, what's the probability of finding a sample with a mean larger than 8 pounds? So what in the world does this mean? Well, it sounds to me like what we're doing is we've got a sampling distribution. I know, you thought you were done with these things. You have the middle, 7.8. So let me just show you where we are. I've got a sampling distribution, meaning that it's a normal distribution. I have the mean, And then I have some number over here, 8. And I need to shade this. It's just like what we did before the break, what you did on the exam, and you did a great job, by the way. So I need to shade this thing one way or the other. What is the probability of finding a sample mean larger than 8 pounds? So Noel, which way am I going to shade this thing? I've got my line, everything's set. Just tell me, do I shade to the left or the right? To the right? Oh yeah, more than is to the right, isn't it? Very good. So we're going to go this direction. And then we're going to pull up Excel. This is so exciting, I know. That's not the Excel that I want. I want this Excel because it's the one that I've been fooling around with. Hold on a sec. And I'm going to do equals norm.dist. You remember the joy of this, of 8, 7.8, 0.098. So many 8s. And true. And that just feels like it's not very big. Let me just make it bigger. Ah, that's so much better. Okay, so some of you know whether here, let's go back to the picture. There's my picture. Here's my answer. 98%. Is that 98%?
No.
Okay, so you're dying to tell me, aren't you, Easton? What did I do wrong?
Excel's leftist.
I love it.
So Excel will always vote for the Democrats.
Okay,
But,
maybe the Green Party, you never know. But yeah, so Excel is leftist, so we need to fix this. The 98% or 0.979 or whatever it is, that represents this over here. And so what I need to do is I need to take whatever's over there, 98%, let's just say. 98% is to that direction, so over here is going to be 100% minus 98%. So all of that stuff that we did with the normal curves, it still applies. And that's going to be 2% is the answer there. So on Excel, though, I would actually do this, equals 1 minus that answer there. Now there's my 2%. Isn't that beautiful? I love it. Okay, let's see what else we can do for fun here. Find the sample mean and sample. Did we do this one? Oh, that one's boring. It's basically the same idea. Oh, it's all right. We'll do it. We'll do it for fun here. Let's see, what do we got here? Yeah. This one. Okay, so let me highlight the numbers. I think that's it. Whew. Okay, so I'm going to skip the word million for a minute. We're going to come back to it. But let's identify the other things here. See, it's not that hard, is it? Hayden, what does the number 1 represent in the context of this problem?
The mean.
It's the mean of the whole population is 1. Next, volunteer. Thank you for volunteering, by the way. Adric, what does the number 2 represent? Standard deviation. Very nice. Now the number, where are we? We're at Jonathan. Jonathan, what about the number 200? What does that represent?
The sample size.
Sample size. So look at this. We're rolling with this thing. Now, the million there. I only highlighted that kind of as not really a joke, but just to sort of illustrate that sometimes, now this really isn't a number, it's just a word, but sometimes there will be numbers embedded in your problem that have nothing to do with your calculations. You don't care about them. For example, if one way that this could be written is an unknown distribution is created by the average number of grams of gold per million tons of seawater. The study was done in 1973. Like if they had the date there. 1973, you don't care about that. I mean, you might, but in terms of your calculations, you don't. So be careful. There will be some numbers that may mean nothing to you that you don't care about. You do care about these 3. Those are the ones you want to look for. So let's do mu sub x bar. What is the new average? You know this. In fact, wait, he just ran off on me, didn't he? Was he offended or something?
Who?
Matthew, he just disappeared. I must have offended him.
I thought he told it to me.
He sure did. No, I think he's got to go play sport ball somewhere. What is it, lacrosse? Wait, why aren't the rest of the lacrosse people, why aren't you guys gone? No? You don't play today? Just the dudes. Friday, what time? Oh, you leave. You don't get to play with here? Oh, well. Okay. Okay, what is the new, Grace, you're the next person since Matthew isn't here. Grace, what is the new mean?
1 gram.
1 gram per million cubic tons, or whatever it is. Next, Lila, right? Okay, what is the new standard deviation? 0.141. You didn't want to round it anymore. And how did you get that standard deviation?
You take the old one and then
2.
take and then divide it with the square root of 200
Beautiful.
million.
200. Oh, interesting. 200 million. Well, this is per million tons, and so you have 200, and each of the 200 is a million tons. This is a terrible problem. Well, hopefully you won't have something like this on your homework. What do we have, 1 minute? We have 1 minute? Okay, well, we've done as much as we can here. Do your best with the homework. Come on up and complain. I already gave points to someone today, so you never know. Maybe you'll get lucky.